Welcome to a lesson on graphing trig functions. This is going to be an introduction to the sine, cosine, and tangent functions. You have your pear deck. We're going to ask you to write your name right on the first screen, okay? This is slide 1 of 9. Then let's move on to the second slide where you're going to review your prior knowledge of these functions that you have learned about in past courses. So you can pick a minimum of any 4 functions. If you can do them all, that'd be great. And just give a sketch. What does a rational function look like? How about a logarithmic function or linear, quadratic, any of these, okay? So put the video on pause and go ahead and think about your prior knowledge. And in this lesson, you're going to be reviewing sine, cosine, and tangent of pi over 2, pi over 3, pi over 4 and pi over 6 families. So we'll be thinking about radians today, okay? In this lesson, you're going to be reviewing special right triangles. And here's a screenshot from your grade 10 math MCAS reference sheet of a 45, 45, 90 and a 30, 60, 90 right triangle. And what about the relationships that exist among those sides? You'll be graphing trig functions, looking for structure and characteristics of trig functions, doing it all by hand without a calculator. So we'll be using the pen tools and different kinds of tools in this pear deck. Okay, we're not going to be graphing trig functions in this particular slide, but we're going to review what we know about the sine, the cosine, and tangent of the pi over 2 family and the pi over 4 family. So what I have here for pi over 2 is I have the 0 radian, pi over 2 radian, pi radians, and 3 pi over 2. And if I asked you what is the sine of 0 or 2 pi, the sine is the second coordinate on the unit circle. It would be 0. The cosine would be the x coordinate. That would be 1. And the tangent, as you know, is sine over cosine. So we're going to be doing 0 divided by 1. So the tangent of 0 radians, or the tangent of 2 pi, is 0. Now let's go on to pi over 2. Sine is the second coordinate. Cosine is the first coordinate. And tangent is undefined at pi over 2. Make sure you can understand why it's undefined. Tangent is sine over cosine. What happens when we divide by 0, right? The sine of pi is 0. Cosine of pi is -1. Tangent of pi radians is 0. And 3 pi over 2, we have -1 for the sine. 0 is our cosine. And the tangent function is undefined at 3 pi over 2 radians. So that's a good place for us to start. If I know these values, if I have them written down somewhere, when I go to graph the trig functions by hand, I'm going to be using the information that's on this chart. Let's move on to the pi over 4 families. Now what I'm going to do is I will highlight in blue. Pi over 4 is right there, so you can see what your sine is and your cosine. So this is 1 pi over 4. This is 2 pi over 4, but we can ignore that because what we're really interested in is pi over 4 above the horizontal and pi over 4 below the horizontal. So this is pi over 4, 3 pi over 4. This would be 4 pi over 4. 5 pi over 4 I'm interested in. 6 pi over 4 is really the pi over 2 family, but 7 pi over 4 I'm interested in. So what we're going to ask is that you interpret what is the sine, cosine, and tangent of these angles. So I'll go ahead and change my text color to blue. And the sine of pi over 4 is the square root, the square root of 2 over 2. The cosine is also the square root of 2 over 2. And tangent, sine over cosine, any number over itself is 1. So that's kind of nice. Let's move down here. 3 pi over 4. Okay, that's this spot. The cosine is negative and the sine is positive. So I can actually copy these numbers and just paste them down right here and change my sign. My cosine is negative because I'm in quadrant 2. My sine is positive. My tangent, of course, will be negative because a negative divided, or what is it, a positive divided by a negative is a negative. Let's look at 5 pi over 4. I'm going to go ahead and copy and paste my values, but then think about my signs. All right, let's look. What are the signs of 5 pi over 4? Well, it's this quadrant. So cosine is negative, sine is negative. So both of these are negative. And my tangent will be positive because a negative divided by a negative is a positive. 7 pi over 4. I'll paste down the values that I had, and now we'll consider positive or negative. 7 pi over 4 is here. My cosine is positive. My sine is negative. And so my tangent's going to be negative as well. Okay, hopefully all that makes sense. And there's a reason why we are reviewing it. It will help us graph. Let's move on to slide number 5, okay? Okay, same thing, but for the pi over 3 and the pi over 6 families. So let's consider this. What I have here is a picture of pi over 3. Now, I know this is pi over 3. I think I'll use purple. I know this is pi over 3 because pi over 3 is 60 degrees. I also know it's pi over 3 because if it's pi radians halfway across the circle, then pi over 3 radians will be a third of pi, right? This will be 2 pi over 3. Of course, I have 3 pi over 3, which I'm not overly concerned with. 4 pi over 3 I am concerned with. And then 5 pi over 3 is right here. My picture is definitely not drawn to scale. All right, now let's zero in on this right triangle right here, okay? If this is 60 degrees, this little angle down here, if that's 60, I want you to notice, well, let's start with this. The hypotenuse is 1, right? Because it's a unit circle. So the radius is 1, the hypotenuse is 1. Now, if the hypotenuse is 1, let's look. This is the hypotenuse. Then the short side, the side opposite the 30 degrees, is half of the hypotenuse. So my short side is 1/2. My long side then is 1/2 times the square root of 3. We call it the square root of 3 over 2. Now, why does this matter? Because I can now determine the coordinates of any point that lies on my unit circle in the pi over 3 family. My cosine, I've gone 1/2 to the right. My sine, I've gone up square root of 3 over 2. So in all of these, I'm going to use 1/2 and the square root of 3 over 2. So I'll go ahead and type that in. My sine is the second coordinate, square root of 3 over 2. My cosine is the first coordinate. And my tangent is sine over cosine. Square root of 3 over 2 times 2 over 1. The 2's cancel out, and I'm just left with square root of 3. So these are good values that I can copy and paste into every other spot in this table. But I just have to think about my signs, right? Are these going to be positive or negative? That's something that's important for us. So let's consider that next. 2 pi over 3. Okay, quadrant 2. Well, in quadrant 2, what do you have in terms of positive and negative signs? To get to this point, I went left and up. My cosine is negative. My sine is positive. So my cosine is negative. Let's look at 4 pi over 3. To get to this point on the unit circle, I went left and down. Both the sine and the cosine are negative. And to get to 5 pi over 3, which is right here, I went to the right and down. My cosine is positive, but my sine is negative. Now look at the tangent. Since tangent is sine over cosine, the tangent of 2 pi over 3 has to be negative. Negative divided by negative is positive. Tangent of 5 pi over 3 has to be negative. So I hope that makes sense to you. Let's look now at the pi over 6 family. And I'll change my color. Let's go with brighter red. And again, if pi radians is right here, if this is pi, pi over 6 is 1/6 of the way to that. So 3/6 of the way is there. So my pi over 6 is right around here. And once again, you can think about this 30, 60, 90 right triangle. Because pi over 6 is 30 degrees, I have my hypotenuse of 1. So once again, the side opposite the short side is going to be 1/2. And the other side is going to be the square root of 3 over 2. So this time, the coordinates of this point, how far in the x direction did I go? How far in the y direction? Square root of 3 over 2 is your x coordinate. 1/2 is your y coordinate. Now these numbers are going to look familiar to you. Right, because turns out the sine, and this is really interesting, the sine and the cosine, let's see, how does this work? If you have an angle, like 60 degrees, the cosine of 60 degrees will be the sine of 30 degrees because the cosine and the sine of complementary angles are equal. So that's just kind of a fun fact. So now I'm going to go ahead to my text box and we can write down for pi over 6 that the sine, the second coordinate, is 1/2. So really I'm just reversing these, right? The cosine is the square root of 3 over 2. And the tangent is going to be the reciprocal of this. It's going to be 1 over root 3. 1 over root 3 if you were to rationalize that denominator, and you should be pretty fluent at that. 1 over square root of 3. We're not allowed to keep that radical in the denominator. We're going to multiply by root 3 over itself. We're left with square root of 3 over 3. So that is your tangent for the pi over 6 family. So I'll go ahead and write root 3 over 3. Okay, now that I have this, these are the values for all of these angles. I'm going to copy what's in there, and then I'll paste it down. There we go. Now we have to think about the sines. So let's go ahead. Let's consider 5 pi over 6. Well, we haven't even looked at that yet, have we? So let's grab our tool, our line tool. If this is 6 pi over 6, then 5 pi over 6 must be 1 up from that. Do you see that? Here is your 5 pi over 6. To get to this point on the unit circle, I went left and up. So my cosine is negative, my sine is positive. 7 pi over 6. It has to be 1 down from pi. So let's say that this is 7 pi over 6. The signs of any coordinate that lies in this quadrant is negative, negative. So both of these are negative. I'll deal with these signs first, and then I'll go back to tangent. Now 11 pi over 6, that's over here. It's 1 below 12 pi over 6. So the sign here is positive and then negative. So my sine is negative. Now my tangent is going to be negative in quadrant 2. It will be negative in quadrant 4. Hopefully all that makes sense. All right, now let's get to the graphing of the trig functions, okay? That's what we're here for. Get to graph our first trig function, graphing the sine of x. Okay, so y equals the sine of x. Here's what we're going to do. X is going to be our radian measure of our angle, okay? Y is going to be the sine. So we're going to look, and let me get my pencil tool and just mark this down. This is 0 or 2 pi, right? This is pi over 2. This is pi, and this is 3 pi over 2. Now let's check out what is the sine or the second coordinate of each of these angles, okay? And I'll grab my text tool. Let's use a fun color. Oh, I want orange. All right, so the sine of 0 is 0, right? Because it's the second coordinate. The sine of pi over 2 is 1. I'm looking at the second coordinates of all of these. The sine of pi is 0. Sine of 3 pi over 2 is -1. The sine of 2 pi is 0. Now I'm at this place where I want you to remember that we can go past 2 pi. One full revolution is 2 pi, right? Or 4 pi over 2, right? Another name for 2 pi is 4 pi over 2. So go a half a revolution more, and I'm at 5 pi over 2. So sometimes it's really helpful to get more than just 0 to 2 pi in there. All right, I'm going to go back to my text tool, and let's continue. So the sine at 5 pi over 2 then would be 1, right? Because I'm back at the 90-degree spot. And the sine of 3 pi, it's pi plus 2 pi is 3 pi. The sine there is 0. So I have my ordered pairs. What I need to do now is realize if this is x and this is y, can I put dots representing these ordered pairs? Absolutely. So let's get our pencil tool, click on whatever color you like. I'll pick the darker orange, and let's size it up just a bit. 0, 0. That's right here. Pi over 2. Oh, so I didn't mention to you how I set up my axes for you. Because I'm counting, this is the pi over 2, I'm deciding to count by pi over 2s. I've just gone every 2 units, I called it pi over 2, then pi, and then I hopped over 2 more, 3 pi over 2, 4 pi over 2, right, which is another name for 2 pi, 5 pi over 2, 6 pi over 2. And now I'm going to graph these points. So pi over 2, comma 1. I go to the right pi over 2 and up 1. Pi, comma 0. 3 pi over 2, comma -1. 2 pi, comma 0. 5 pi over 2, comma 1. 3 pi, comma 0. And we can start to see this pattern as things are oscillating, right? They're varying. And so if I were to go backwards, negative pi over 2, the sign of negative pi over 2 would be -1. And that makes sense because this is negative pi over 2, and the sign is -1. The sign of negative pi is 0. The sign of -3 pi over 2 is +1. And this fits the pattern. And what's so nice about math is you're always expecting these patterns. Things always have a really nice flow. So I don't want to go on a tangent, so I'm going to leave that alone. No pun intended for tangent. Now what we're going to do is we're going to go ahead and connect these points. And the way this works, it's kind of like, this is not a linear function. Not at all. So don't connect them with a straight line. We are not going to be using this line tool. We're sizing down our pencil, and we're going to think of this almost like the way we used to graph the polynomial functions. You know, everything is just kind of smoothed over. You see, I just had to move my pen, and this is going to continue. This is going to continue oscillating like waves. We call these sine waves, and believe it or not, this has a really good, if I remember correctly from I didn't love that one. I'm going to undo that. If I remember correctly from college, I think this has something to do with electricity. For some reason, I'm remembering that the way electricity flows. I could be wrong, so double check that. But there's your sine curve. How nice. You graphed your first trig function by hand without a calculator. Now, what if I went to check it on Desmos? We can do that. Why not? You can always check things on Desmos. Now, I just don't know if Desmos will put it in radian mode or if Desmos will put it in degree mode. Now, if it is radian mode, right, this is what we want to think about. This top hump, pi, remember, is like the number 3.14. So you'll see almost a 0 at 3.14. Then you'll see another 0 at 6.28, like that. All right, let's just check. Let's do y equals, or do f of x. I like f of x, equals sine, there's sine of x. Ah, look what we got. Oh my goodness. How nice is this? Look at these values. Exactly what we expected, right? And there's that sine curve. And if I zoom out, you're going to see it goes on forever unless you restrict the domain otherwise. And there it is. So that is your first taste of graphing a trig function.